Good afternoon, everyone. Am I audible?
Yes.
Yes. So I welcome all of you.
Hello.
Yeah, madam, please tell me.
Yeah, sir. Actually, I wanted to ask, do we have to install NetBeans and Eclipse both, or any one would be fine?
I'll tell you, madam. Actually, you need to install two only because some softwares are compatible with NetBeans and some softwares are compatible with Eclipse.
Okay.
But you can do. There is some path setting is required. Apart from that, you can run both the things in NetBeans and Eclipse.
Okay. Okay. Okay.
Okay. So once again, good afternoon to everyone. Welcome to all of you to the day 7 of our uh, online faculty development program on cloud and fog computing platform for IoT application organized by E&ICT and Department of CSE and IT Warangal. So today we have two sessions. In the first session, we will discuss about the two tools. One is CloudAnalyst tool, which is a very popular tool in the field of cloud computing. And I'll also tell you about one of the another tool that is called as iFogSim. That is very popular for creating different kind of topology in fog computing environment. So we'll see one by one, and the next session we'll see job scheduling for big data computing in heterogeneous environment using machine learning. So I request all of you to download CloudAnalyst. You can go to chat box. In chat box, I have shared two links. One is for CloudAnalyst. So this site you can download CloudAnalyst, which is a very small size, that is 5 MB, I think. And similarly, I have also given the link for iFogSim master, which is available in GitHub. So that you can download. Okay. Or any source you can download. These are the two sources where you can download. And in order to run CloudAnalyst, it is suggested to go for NetBeans, but you can use Eclipse also. But I am using NetBeans. In this session also, I am going to use NetBeans to illustrate CloudAnalyst. And system configuration, as I mentioned in the chat box, if you see, you need to install JDK. I think most of us are having JDK because the day-to-day applications, whatever we are using in our computer systems, they are Java enabled. So JDK must be there. If it is not there, then you have to install it. Once JDK is successfully installed, then you can download NetBeans and do it, because automatically it will take the path. If you do both things simultaneously, sometimes path issue is there, so you will get some kind of error. So let me download NetBeans CloudAnalyst from here. NetBeans size is more in comparison to CloudAnalyst. I think NetBeans is 200 MB around, so it will take some time. So please download these two. So I'm downloading now CloudAnalyst. And now it is downloading in my system. So it is around 3.7 MB. So it will be available by default in your download folder. So this is my CloudAnalyst. You can cut and let me paste in our material folder. Also, I have provided in my material folder day 7 all the softwares. So let me rename as CloudAnalyst only. Okay. So all the softwares are available in day 7 folder. All the relevant, you can say, relevant study materials are also available inside the CloudAnalyst and iFogSim folder. Now what I have to do, I have to open NetBeans. So in my computer, I have old NetBeans, but you can download the latest NetBeans. There is no issue. So I am using NetBeans IDE 8.0.2.
Sir, can you share the link of NetBeans also? Download link of.
NetBeans you can download just a minute. Yeah, you can use this one.
Yeah, I've opened this one only, but I can't see the option of download here.
Okay, let me check. Otherwise, you'll download from any other source. Yeah, here Apache NetBeans is also there. That also you can install. There is no issue. But the size is very large in comparison to normal NetBeans. Okay, otherwise, what I'll do, I'll give you the NetBeans software inside the SAD folder, so you can install later. Okay, so this is the first page of NetBeans. When you install NetBeans and open NetBeans, then you will get this field like this, a page like this. So the prime requirement is our JDK. In my system, JDK is already there. So NetBeans is installed with JDK. Now let me open my CloudAnalyst folder. So if you go for this CloudAnalyst folder, so it is a zip file. I kept the cloud analysis outside to show you, and the details about cloud analysis you can find in day 7 folder. So it is a zip file. So I request all of you to unzip it. Click extract all, extract. Those who are not getting cloud analyst, you can directly go to our materials folder, which I have shared you in WhatsApp group also. You go to WhatsApp group description, there this link you can find, and you can directly download from my Google Drive. Okay, now cloud analysis successfully unzipped. You can see. Okay, so what you have to do, have to go to NetBeans. So this is a Java project, like we write Java program or we execute Java project. So this is also a Java project written in Java. So cloud analyst is basically it is completely based on a modular design that can be easily extended. Some modules are already developed. Some modules you can do as a part of research. It is developed using various technologies, not only this NetBeans or JDK. We need also Java Swing, or we need specific versions of Java. Means you can go for Java 1.6 version onwards. Any Java version is it's okay. Similarly, Sim Java is also providing some features in this particular tool. But the basic requirement is that you have to go for a IDE and a JDK. So there is no project here. So in order to add that project, I am writing file. I'm going to this path, file, then open project. So here I have to specify the folder. So I'm going to this PC. Inside that I have to provide the path of my cloud analyst. Cloud analyst folder. Okay, here you can see there is a Cloud Analyst folder, and you can see there is a icon here, which shows just like a coffee mug icon. Okay, so in this folder, actually my Cloud Analyst is there. Just I am opening that project, nothing else. Okay, so what we have done till now, I have given a link in the chat box. So just open it in your browser, download Cloud Analyst, and make sure that you have NetBeans in your system. If not, download NetBeans, or you can use any IDE and open the Cloud Analyst. When you download Cloud Analyst folder, it is a zip file. First unzip that file and locate that particular folder and open that file as a Java project. That's all. And once you see this coffee color icon, it indicates that you are in correct way, correct path. Till now, whatever you have done, whatever configuration you have done, that is correct. Okay. So I'll go to day 7 folder. I'll tell you a little bit theory before proceed towards Cloud Analyst. So you can refer this paper, which I've already said. The paper name is called as Cloud Analyst, a CloudSim-based visual modeler for analyzing cloud computing environment and applications. Okay, so here you can see in figure 2, it is showing the Cloud Analyst architecture. Cloud Analyst is based on the CloudSim. In the background, we have CloudSim only. And on top of CloudSim, you have CloudSim extension and GUI, that is graphical user interface. And on top of CloudSim, what we are doing, we are creating Cloud Analyst software. So it is basically a GUI and a CloudSim extension, which you can see in the figure 2. This is the architecture of Cloud Analyst. So in the background, what we have? We have CloudSim Toolkit. Okay, so you know it is very difficult for anyone to write the code in any type of tool. Writing code becomes very difficult. So developer face a lot of difficulties prior to the development of Cloud Analyst. So developer not only focuses on the application logic, how to write code, but also they focus on how to deploy application, how to host an application. So there is a lot of burden on the developer, right? But through this cloud computing or this Cloud Analyst tool, it enables the developer to focus only on the application logic. If you want to develop a software or an API or an application, so you have to concentrate on how best you can design a application. Okay, right? But we are not worried about how to deploy an application or how to host an application. So in order to facilitate that, we have a tool like Cloud Analyst. Okay, so let me go back to my NetBeans, and you can see there is a run button here. I'm not doing anything. I'm only simply unzip my Cloud Analyst, add it as a project. I will show you the code later. Then simply you click run project. So I'm getting some kind of error. Okay, just a minute. Let me try again. I'll open the project. This time, let me give otherwise whatever there in Cloud Analyst, the folder inside the day 7. So this is my CloudAnalyst folder. So let me extract it. Sometimes you may get error. So simple solution is that again use unzip it and load as a project. That's all. Okay, let me try. Still I'm getting error. Fix it. So let me copy this file and paste in my desktop. I think the path is very long. That also may cause a problem. Okay, now I am trying with another folder. Let me see, is there an issue or not? Yeah, it is expected to get this particular screen after running CloudAnalyst. Yeah, till now anybody is having any issue, please let me know. So if you are getting any error, so my suggestion is that you change the folder, put the zip file in another folder, like I put in my desktop folder, and unzip it and open this as a this as a project. Yeah, anybody is having any issue till now?
Excuse me, sir.
Yeah, madam, please.
Hello, sir. Can you repeat? Sir, actually, I'm trying to do it in Eclipse. Does the
Yeah.
system also require internet to run some
No,
import
no,
files,
internet is
or will it?
internet is not required, madam. For this, internet is not required. It is only running in your system. Like Amazon, you have seen you are dealing with the real servers, but here we are not doing daily with any other server. So no internet is required. Internet is required to download the software. Internet is not required to run this software.
Okay, sir.
Okay, if you are facing any difficulty, please let me know in chat box. There may be some difficulty, like I faced also. It is not. It is showing some kind of error, but it is expected to reach to this particular screen. Until unless you reach to this particular screen, so you try to explore unzipping the file and open in this Cloud Analyst as a project. Okay, so what you can see in this screen, you can see something is mentioned as DC1, that is called as data center 1, and which is in red color, and you can see something is written as UB1, that is called as user base 1. So user base 1 and DC1, they are present in two different locations. So like that, like you have seen in AWS, Amazon Web Service, there are several regions we have. Like we have AP South 1 region. AP stands for Asia Pacific. That is a region. Similarly, if you look into US, we have US East region, US West region, and also East case also we have two region. West case also we have two region. What Amazon did? Amazon has divided the whole world into different regions, right? Similarly, here also we divided this world map into various regions. So if you want to see the region boundary, this is you are seeing geographical boundary, like every country or continent, geographical boundary. You can see geographical boundary, but if you want to see the region boundary, so there is a button in the right corner which shows show region boundary. So when you click show region boundary, you can see there is a colorful map which shows the different boundaries. For example, this particular region, we call that as a region 0, which is mentioned as R0. This region is said to be R1. This particular region is R2. This big region is R3. This region is R4, and this particular region is R5. That means this particular tool divides the whole world into 6 different regions, starting from R0 to R5. Okay, like that, suppose you want to set up some kind of simulations in which you want to specify more region or less region. So you have to simply modify the code. Right, by default, it is showing 6 different regions starting from R0 to R5. Okay. And if you again click this show region boundary, then the boundary is going to be removed. Okay, these buttons use only to show the boundary and remove the boundary. Okay. Now, in the left corner, you can see there are 4 buttons. One is called as configure simulation, define the internet characteristics, run simulation, and exit. And simply when you click exit, you will be again back to your NetBeans. Right? When you click this one, you will back to NetBeans. And there is no manual given here. So although there is a help button, it is showing details about this software. That is, this is V1.0 beta created by the first author of this paper. You can see. And the email ID of the first author. Right? So there is no manual attached to Cloud Analyst. Okay. So now, one by one, we'll discuss. So let us go to configure simulation. Under configure simulation, you have 3 tabs. One is main configuration, another is data center configuration, another is advanced. So before discussing these configurations, let me tell you about some theory so that you can understand how actually these two works. So You have seen in the front page of Cloud Analyst, there is something written as DC1, data center 1, and another is UB1, that is called as user base 1. Okay, so DC1 is your data center 1, UB1 is our user base 1. Okay, normally user makes a request to the data center to get some kind of services. So in Cloud Analyst, the events are grouped at 3 levels. So we divide into 3 different levels. Any events we are doing, events is considered as your user base. So they are grouped into 3 levels. In the first level, we have user bases. Generally, a user base indicates clusters of users. So not only a single user, a group of users are making a request. So we call that as a cluster of users. And they are handled as a single unit. UB1 may contain the request of one or more number of users. Right? When you go to the second level, user requests are generated from each region user base are grouped based on the grouping factor. So although there are multiple users are there, they can be grouped based upon a grouping factor. So I'll show you this grouping factor in the advanced step. A second level is based on the grouping factor. Third is that how many requests you can simultaneously process by a single virtual machine. That is also need to be grouped. Okay. How many at a time? Suppose I have 10 virtual machines. So I can execute 10 requests at a time. So grouping of virtual machines, that is also another grouping factor. So one grouping vector is with respect to the user base, another grouping vector with respect to the virtual machine. Okay, so these two are given in our advanced step. Okay, so let us see how actually this cloud analyst work. So cloud analyst, as I said, we have some data centers. I'm showing you one data center for simplicity and one user base for simplicity. But in any real life applications, we have a large number of data centers and large number of user base. So our first objective is to map the user base with the data centers. Okay. So we have to map the user base with the data center. Assume that you have UB1, UB2, like that, let's say up to UBM. Right? On the other hand, you have DC1, DC2 up to DCN. So M is greater than N. So number of user bases are normally greater than N. So this is also a set. This is another set. Right? What you have to do? You have to do mapping. For example, you have decided that UB1 will assign to data center 1. UB2 is assigned to, let's say, data center 3. UBM, let's say, assigned to again data center 1. That is also one type of mapping. What actually we are doing? We are doing traffic routing. So somebody has made a request. So we route that request to the data center. That is called as traffic routing. So the process of mapping the user base to the data centers is called as service broker policy. Service broker policy maps the user base to the data center. Right? And there are 3 different type of policies which we can see here. One is called as closest data center. Closest data center. Another is called as optimize response time. Optimize response time. Third one is reconfigure dynamically with load. These are the 3 policies that are available under the service broker policy. So let us see where it is available. So if I go to my cloud analyst, Okay, so here you can see something is written as service broker policy. If you open this drop down menu, you can see there is 3 policy. One is called as closest data center. Second one is called as optimized response time. Third one is called as configure with reconfigure dynamically with the load. So default policy is which one? Default policy is closest data center. So that means this policy routes traffic to the closest data center in terms of network latency. Okay. For example, let us try and with an example so that you can understand. For example, a user base has 3 options. It can connect to data center 1, it can connect to data center 2, it can connect to data center 3. Right? So suppose the network latency, latency means delay. The network latency from UB to data center is assumed that let's say 5 milliseconds. This is let's say 15 milliseconds. Let's say this is 5 seconds. Some time unit. So obviously which one is least? The least one is the data center 1. So the user base will connect to the data center 1 because the network latency is low in comparison to others. And this closest data center is considered as what? The default policy. Okay. If you are not selecting anyone, by default it is closest data center. Okay. So in addition to that, we have another 2 policy. Another is called as optimized response time. Sometimes a particular data center is having more load. Okay, it has more load. So it is occupied. Its resources are fully occupied by early arrived user bases. So in that case, we need to consider the optimized response time. So if you take an example, let's say for user base 1, it has make a request to data center 1, also to data center 2, also to data center 3. Right? Now, we are calculating the response time. Although data center 1 is close to that user base, but the response time what we got is let's say 15 seconds. However, data center 2 is away in comparison to data center 1, but its response time is let's say 1 second. Similarly, data center 3 again far away in comparison to DC1 to DC2, but its response time is let's say 5 seconds. So obviously, which data center you will choose? You will choose the data center DC2. Okay. Not only the closest distance is important, but also once your request reaches to a particular data center, how faster you are going to get the service. For example, DC1 is closed, but if you look into its queue, it is all the tasks are filled. So it is not going to get the request. It has to wait and get the request. So in that case, optimized response time is better. The data center which gives us better response time. We need to consider that even if it is away with respect to the distance, right? So sometimes optimized response time is also better in comparison to the closest data center. Okay. Third policy is called as reconfigure dynamically with the load, right? So for example, there are multiple user bases. Assume that I can say, let's say for UB1, UB2, UB3, all these has made request to the same data center, DC1. DC1 going to be overloaded, right? All are making requests, so it will reach to a peak, highest resource utilization. On that case, what DC1 will do? DC1 will collaborate with another data center. Okay. So it attempts to share its load. Data center 1 is attempts to share its load with another data center. So DC1, DC2 combinedly providing services to all these user bases. what we are doing? We are dynamically changing our topology. Dynamically, we are changing our configuration based on the load. If load can be handled by DC1 alone, then it will do it. When it see that there is already peak arrived, it is not possible to handle more requests. On that case, DC1 will collaborate with another data center, okay, and provide the services to all the user bases. Okay. So what you can do, you can put a predefined threshold when the original data center, in this case DC1, performance degrade above a predefined threshold, then we will go for the data center 2. Again, you can put a threshold when the threshold is below the performance on data center 1. Data center 1 will not take any resource from the data center 2. Okay, if it is exceed over provisioning, then in that case DC1 is collaborating with DC2. When there is under provisioning, at that time DC1 alone can provide the resources. Okay, so this is one policy that is called a service broker policy. Is it clear? What is the difference between 3 different policy? Closest data center, optimize response time, reconfigure dynamically with load.
Yes, sir.
Yeah. What you can do, you can also add another service broker policy here. Okay. You can add another resource broker policy by applying some technique, and you can show that your service broker policy is better than closest data center, optimize response time, reconfigure dynamically. But no, that is a research contribution. In fact, we have also added some new service brokery in last 2-3 years. Okay, this is the first part. I'll tell you the rest part later. So the second one, once your request is reached to the data center, the job is over. Right? These policies are designed to make a route between user base to the data center, right? But there are some other policies are also there. There is another policy that is in between the virtual machines to the physical machines. So I can write here, a data center contains a set of servers, or we can say physical machine. In each and every physical machine, you can create a set of virtual machines, right? So overall, we call data center. Inside data center, we have physical machines, right? So under a physical machine, we have a set of virtual machines. So mapping between VMs to PMs is also important. For example, let us consider a PM1 and PM2. PM2 capacity, PM1 capacity, let's say 1000 in some unit. I'm not specifying unit for simplicity. PM2 is having, let's say, some size 500. Now you have, let's say, 4 virtual machines: VM1, VM2, VM3, and VM4. VM1 is 100, VM2 is 200, VM3 is 300, and VM4 is, let's say, 350. Right? So if you see the total requirement by these 4 virtual machine, okay, it is 300, 300, 600, another 350, it is 950. So all these virtual machines can be hosted by the physical machine, because physical machine capacity is 1000, and all 4 virtual machine together, it is 950. So they can be accommodated in the physical machine, PM1. So there is no need of PM2. PM2 can be put in the switch off mode, right? But if you see another virtual machine, if I take virtual machine 5, which is having capacity 450. So it is not possible to host that in physical machine 1. As physical machine 1 is left with only 50. So in that case, what you will do, VM3 is going to be hosted by the physical machine 2. Okay. Physical machine 2 or physical machine 2. In that way, physical machine 1 and physical machine 2 is maintained. So you need some kind of policies to decide which VM is going to assign to which physical machine. So that policy is also available in our cloud analyst, that is called as VM provisioning policy. VM provisioning policy. But there is a lot of scope to implement the VM provisioning policy, because in cloud analyst it uses a random policy. Mapping of VM to PM is random. So for example, if I go for a random policy, let's say in the same example where we have taken two physical machines, let's say VM1 is randomly assigned to PM2. Okay, then VM2 is assigned here. So VM1, you know, the requirement is 100. VM2, the requirement is 200. VM3 is, let's say, again it is assigned to here, so it's 300. Let's say VM4 is assigned to here, so it is taking 350. Now VM5. So VM5, if it is assigned to PM2, we cannot assign it, because 100 plus 350 together it is 450, and the maximum capacity of physical machine 2 is 100. So VM5 is not at all assigned here. It can only be assigned where? If I am assigning VM5 to here with 450, because it is having 200 plus 300, so 500 plus 450. Okay, so that can be assigned. So random policy case, what happens when it is over provisioned, you will not able to assign the virtual machines to the physical machine, right? Sometimes random decisions are good, but maximum cases you will find these decisions are not good. So if you can develop a VM provisioning policy and replace that Java file with random policy Java file, then you can see the performance can be improved. So that is the second part, which is not explicitly shown. This part is not explicitly shown in Cloud Analyst. This you can see in Service Broker policy, but this you cannot see in the GUI, graphical user interface, right? Now there is another policy which is called as load balancing policy. Load balancing policy. So normally if you go to AWS, you will find there is a load balancer, right? So there are many requests reached to, any request may be submitted by different users to this load balancer. Okay, and behind load balancer, what you have? You have different servers. So the objective of load balancer is to equally balance the load to different servers, such that they are not underutilized, they are not overutilized also. So load balancer plays an important role between the user and the resources. Okay. So why load balancer policy is used here? The load balancer policy assigns the request. Request means our user bases across the VMs under a single data center. In a single data center, suppose you assume that you have 10 virtual machines. These virtual machines are created on top of our physical machines. So load balancing policy is to how you are going to assign these user bases. Okay, let's say UB1, UB2, UB3 to these virtual machines, so that every virtual machine will get equal load. So in our cloud analyst, we have three different policy. One is called as round robin policy. Second one is called as equally spread current execution load. Execution load. Another is throttling. These are the three policies that are already available in Cloud Analyst. Okay. Again, there is a scope of improvement. You can add contributing load balancing policy. You can contribute in service broker policy. You can contribute in VM provisioning policy. You can also contribute in the load balancing policy. Okay. So let us understand these policies. What is round robin? For example, you have 3 virtual machines, right? Assume that you have user base 1 is having 5 tasks that I'm writing UB11, UB12, UB13, UB14, UB15. These all are belongs to, let's say, user base 1 only. I told you inside user base there is a cluster of user, and one particular user can generate one or more requests, right? So how you are going to assign? Round robin says that you assign UB11 to BM1, UB12 to BM2, UB13 to the BM3, then UB14 to BM1, UB15 to BM2. That's all. So it is a fairness with respect to how many requests you are making to individual virtual machines. So it got two, it got two, it got one. So it is equally balanced, right? It is equally balanced. 2 to 1 means it is more or less last machine only it has got one, but other virtual machine got two, right? It is equally done. But we should know that what is the execution time of this user base. For example, assume that the user base 1 takes 2 minutes to execute. It is taking 3 minutes. It is taking 5 minutes. Okay, it is taking, let's say, 7 minutes. It is taking 9 minutes. Okay. So in this case, if you look into, it is not fair, right? Because if you see execution time, UB1 and UB14, UB11 and UB14, together they have 9 minutes. UB12 and 15, they have 12 minutes, and UB3 has 5 minutes. So no doubt, with respect to the number of user base, it is a fair one. But if you look into the execution load, that is not fair. And also, before arriving these user bases, maybe these virtual machines are busy with some other assignments or other user bases. So that load also we are not considering. That's why round robin may not perform well if there is a uneven load. But when you say that there is a even load, in that case round robin can perform well. So what we can do, in the case of, to avoid this round robin policy, but round robin is said to be the default policy. Like I told you, closest data center is the default policy. Round robin is the default policy, load balancing policy in CloudAnalyst. If you are not selecting anything, by default it is round robin. So
Sir,
second policy, yeah.
sir, in case of when we came to distribute UB15 or
Hmm.
UB14 after
Hmm.
distributing 3 to VM,
Hmm.
was it not random? Like UB15 could be distributed to VM2 also or VM3 also.
It is not random. Round robin follows one particular sequence. In that
Okay,
sequence only
not
it is assigned.
okay.
Yeah, that what I told you, that is VM provisioning policy. That is
Okay,
mapping between VMs to PM is random.
okay.
But now we are talking about
User
UB
VM.
virtual machine.
Yeah.
Yeah, that is not random.
Okay.
Okay. So we have another policy in order to avoid the drawbacks of round robin, that is called as equally spread current execution load. Although this is considered as one of the future policy, but we need to consider the execution load. Like you can see, if I consider the execution load, this is uneven. So what I can do? So total, if you sum this thing, 9 plus 7 plus 5 plus 3 plus 2, how much you will get? I think you will get a 26, if I'm correct. It is 5, 5, 10, 17, and then 26. How many machines we have? We have 3 machines. So 26 divided by 3, how much you will get? 8 point something. Right. So we have to see that each machine should be get 8 point something load, if possible. So what I can do, one solution can be, this is not a exact solution, but I'm telling randomly. What I can do, I can assign UB15 in virtual machine 3. So it will take 9 minutes. Then what I'll do, I can assign, let's say, UB11 and UB14 into one machine. So it will take again 9 minutes. It is also 9 minutes, right? Then UB12 and UB13, it is 8 minutes. Okay. So now you can see more or less the load is same. Right. Always here and there will see load is properly, the load never be properly balanced. That is the fact, right? But more or less they are getting the same load. So obviously, in comparison to this particular solution, this solution is much more better, right? So that can be executed, that can be generated using this particular policy. So there is another policy that you can see that is called as throttled policy. What it does. So in this policy, we limit the number of requests being processed in each virtual machine, like VM1, VM2, and VM3. Suppose we know what is the limitation. Okay, VM1, VM2, VM3, what is the limitation of each and every particular virtual machine? Suppose VM3 is a very powerful machine. We assume that. Okay, so its limit we have fixed that it can accommodate, let's say, 5 user base. Let's say VM1 is next powerful machine. It can execute, let's say, 3 requests. VM2 can execute 1 request. Okay, or we can order based on their power. I can keep VM3 first, VM1 second, and VM2 third. Okay, so this policy actually limit the number of requests that is going to be solved in each and every virtual machine, and that threshold is called as throttling threshold. Okay, it will not accept if you give more than 5 requests. But in real life, many requests is reaching. We cannot put a limit 5. So if more than 5 requests are there, it is putting in a queue. Every virtual machine has a queue. So they are putting in a queue. So out of these 5 virtual machines, let's say one is completed. Then another user base is going to be loaded into that particular virtual machine. So we maintain a queue for each and every virtual machines. If a particular number of requests exceed the number of capacity, or you can say throttling threshold, then they have to wait until unless one of the virtual machine is free. Okay. So in this way, this particular policy works. So what you can see in these 3 type of policy, which I told you, service broker policy, VM provisioning policy, load balancing policy. If you want to contribute, one of the policy you can do a policy design between user base to data center, or VMs to PM, or VMs to let's say user base to the VMs. So if you want to design a particular policy out of these 3, other configurations are the same only. We are not changing other configuration. So building a cloud computing platform or cloud computing tool, it is not practically possible for a single individual, single person. What we can do, but we can develop a simple policy, either a load balancing or VM provisioning or service broker policy. And if we embed that into this cloud analysis tool, then we can see the performance. If our good performance we can achieve, then definitely it is part of research work. Considered as a research paper also, right? So with these overall introductions, these are the things which you are going to get in cloud analyst.
Sir,
Yeah,
can
please.
you please once again explain the throttled one? I missed that.
So in this case, each virtual machine is having a threshold, which we call as throttling threshold. For example, in the VM1, I put a threshold of 3. VM2, I put a threshold of 1. VM3, I am putting a threshold of 5. 5 means at the max you can execute 5 different user base at a time. Like we have seen, on top of the physical machines, we are creating the virtual machines, right? So these virtual machines are taking the resources from the physical machines. So we can run simultaneously 5 number of user requests or user base. So what throttling scheduling is saying, it is putting a limit for each and every virtual machines. If number of user base exceed a particular threshold, they should be put in a queue. That's why each virtual machine is having a queue. right? So once, let's say now I'm ordering these virtual machines in more powerful to less powerful. So VM3 is going to come first because it can accommodate high virtual machine. VM1 will come second, so it is handling three user bases, and VM2 will come at the end because it can handle only one user base. So for example, I am assigning 6 different user base to virtual machine 3. So 5 user base is going to execute, another will be put in the queue. And when one of the user base is successfully completed its execution, then this user base is going to be loaded into VM3. Okay, the new concept here is we are putting a particular threshold, that's all. And we are maintaining a queue to keep the thing. Is it clear?
Yes, sir.
Yeah. So you can develop some new policy based on, like, many people have focused on how much power is consumed in each and every virtual machine. Not only how much request you can execute, like, if we switch on a powerful machine, definitely power consumption is also more. Like server case, power consumption is more. Workstation case, power consumption is less comparison to server. Personal computers, the power consumption is again less. Smartphone, again power consumption is less, right? So based on the power you can do, or based on the cost also. For example, if you are getting a service from a particular virtual machine, it may be costly, right? If you are getting a virtual machine which is not that much powerful, that in that case cost is less. So some factors you need to consider in order to dispatch your user request to the data centers or the virtual machines. So let us back to our cloud analyst so that we can discuss whatever things we have discussed. The same thing you can get here. Here you can see the first option that is given, that is called a simulation duration. So by default it is 60 minutes, and it indicates that in real life environment it will run for 60 minutes. Okay, but as it is a simulation, you will get your result very frequently, not after 60 minutes, right? But it is a, you can say, a visualization of 60-minute experiments. Okay, but it is not take 60 minutes to generate your output. Okay, so again you can change here based on the requirement. Minute, hours, days, all the options are given. Based on requirement you can change, or you can change this value also. Suppose I want to change it to 100 minutes, that I can do. Okay, it's simply you have to change, you have to click it and change the particular value. Now coming to user base, as I showed you that there is only one user base that is available in region number 3. Sorry, region number 2. Region 2 is actually R2. So its sequence is 3. R0, R1, R2. So suppose I want to change it to region number 1, that I can do it. So once you change its region to 1, if you click done, then you can see UB is available in region number 1. Earlier it was with region number 2, but now it is moved to region number 1. Okay, so now you can see some of the other parameters what we have. So for example, how many requests per user per hour? For example, here it is saying 60 requests per user per hour. Assume that you have 10 users. A user base means a cluster of user. A user base is a cluster of user. So cluster of user means, for example, in your user base, you have 10 different users. Let's say each user is having 60 requests. It is asking 60 requests per user. So total how many requests you have? 600. Okay, 10 users. Each user is having 60 requests. Okay, so total number of requests is 600. And this is not request per user, this is request per user per hour. So per hour, we are generating, let's say, 600 user requests. If there are 10 users and 60 requests per hour. Okay, that many requests you are making to your data center. Similarly, you can mention what is the data size per request. Generally, it is considered like if you execute a particular instruction, every instruction is having associated with data. Like if I write move A, B. So I'm moving the content of a register, one register to another register. So every register is having some amount of data. So that is going to be moved. So similarly, the data size is 100 bytes. Okay. And in cloud, we have also different types of pricing schemes. These pricing schemes are based on the different hours, the number of hours you have used. Generally, the hours is divided into two parts. One is called as peak hour, another is called as off-peak hour. So peak hour, the cost is more. Off-peak hour, the cost is less. So in general, we consider 12 p.m. to 12 a.m. is considered as a peak hour. And 12 a.m. to 12 p.m. is considered as off-peak hour. Because night time the usage is less. That's why it is called as off-peak hour. So that particular time, it is in general way or default way, right? But if you want to change, suppose somebody will say that morning 9 to let's say evening 9, people are using more resources. So you can change your peak hour to 9 a.m. to 9 p.m. Okay. For example, here you can see it is showing you GMT time. It is not in Indian Standard Time. So you know that is very famous time is GMT time, right? So it is mentioned here that the peak hour start at 3 as per GMT and close at 9. So if you want to change it, you can change it. And as I said, there is a peak hour. Obviously, you have to look into how many users are accessing the system. So average peak hours is 1000 and average off peak hours is 100. Obviously, number of peak users is greater than the number of off peak users. Right? Peak means what? Maximum. So 1000 is the number of users are available. That is in average. And 100 is the off peak users. So like that, you can create multiple user base. For example, I want to create another user base in region number 1. That I can do it. So when you click OK, so you can see there is 2 user base that resides in the same region, that is R1. Okay. So similarly, let us create some more user base. Like I have created a user base in region number 2. I have created another user base in region number, let's say 3. Created another user base in region number 4. I've created another user base in region number, let's say 5. Or I'll create another user base in region number 0. Let's say so many user bases I want to create. Suppose I want to create 10 user base. And last 4 user base I am keeping in region number 0. So when you click done, then you can see a group of user bases are now available. And per region, I have created 1 user base. You can see there is 4 user base here, 2 user base here, and 1 in R2, another in R4, another in R3, another in R5. The total user bases I have created is 10. You can create as many as number of user bases. There is no issue. So for a simplicity, I have created only 5 different user base. Okay. So now the next process is what we'll do. We'll create the data center, right? And before the data center deployment, you can see I already showed you this service broker policy, that is closest data center, optimize response time, reconfigure dynamically with the load. Let us go for optimize response time. Okay, because the data center which is providing you a better response time, your user base is going to locate to that particular data center. Okay. Now under application deployment configuration, you can add the data center, but you have to create the data center in data center configuration tab. For example, here you can see we have only one data center. That data center has created 5 different virtual machine. The image size of that particular data center is 10,000. Memory available is, let's say, 512 MB. Bandwidth is, let's say, 1000 Mbps or something like that. Okay. So if you want to add, you will get an error because in your data center configuration, you have only one data center. So when you click add new, you are going to get a message that all available data centers seem to be allocated. So please create a new data center before you can create further allocation. Okay. So let me go to the data center configuration. In data center configuration, you can see we have DC1, which is situated at region number 0. Okay. And it follows x86 architecture. So we know there is two type of architecture, x86 and x64, but there is only one option given here, that is x86 architecture. The operating system which is used in the data center one is Linux operating system, and there is a virtual machine monitor. VMM is called as your virtual machine monitor or manager. It is also called as hypervisor. The job of VMM is to create the virtual machine by taking the resources of the physical machines. So it is creating VM by taking the resources of the physical machine. So one of the popular VMM is called as XCN or VMware or KVM. These are some of the virtual machine monitor or manager. So here by default it is given XCN. So there are some costs associated with the data center, like cost per virtual machine, dollar per hour. Like Amazon case also, whenever we create a, that is, we created a, in Amazon case, we have created a virtual machine, right? We have created an instance, EC2 instance. So in that EC2 instance, you have seen that the cost is the nominal charge they are taking, right? Cost is always calculated dollar per hour. So here it is saying if you want to use a particular virtual machine, you have to pay dollar 0.1 per hour. But this is a simulation. You are not going to be charged because developer has to estimate what is the cost it has to pay to the provider, right? So it is estimated as $0.1 per hour. Similarly, memory cost, if you see, it is $0.05 per second. Storage cost is $0.1 per second. Data transfer cost is $0.1 per GB. And number of physical units that is associated with data center is 2. Every data center is having multiple server. So how many servers is attached with DC1? 2 servers. So once you click this one, you can see the setup of 2 different hardware unit or servers. In the first tier server, they are homogeneous servers because their configuration is fully same. But you can make it heterogeneous if you change the value. For example, in a particular server, we have 204800 amount of memory and this much amount of storage, this much amount of available bandwidth, and number of processors that are available in server 0 is 4, and processor speed is 10,000. Okay, they are units with respect to their parameter, and the VM policy which we are using, it is called as time set policy. So in CloudSim, we have two type of policies. One is time set policy, and another is called space set policy. If the space allocated to a particular user, if it is also given to any other user, so space is divided. Or time, whatever time it is allocated to you, suppose multiple users are using that particular time, that is called as time set policy. So there are different type of policies we have that you can go through CloudSim research article. There you will find 4 different diagram which defines the time set policy and space set policy in more detail. So similarly, another machines is having also identical configuration as the ID 0. Suppose you want to increase the number of hardware units. Every data center is roughly is having 50,000 to 80,000 server. Here we are showing number of physical units is only 2. So if you want to add, suppose I want to copy this configuration and I want to add. Okay, so you can see it is added another one. Okay, for example, I want to take multiple copies of this one. So I can simply copy It is asking how many copies you need. For example, I need, let's say, two copy. So when you click OK, so you can see another 2 copies later. The number of physical hardware unit is showing 2. Once you click here, it will be updated to 5. So earlier we have only 2 hardware units. I have created one and I have copied the configuration with another 2 uh, physical servers, right? So total number of physical servers that is available is 5. Okay, so it is a powerful one. Now I laid another data center, let's say in region number 1. I laid another data center in region number 2. Add another data center in region number 3. Add one more data center in region number 4. Add one more data center in region number 5. Okay, and so on, right? Or if you want to add multiple data center in the same region, that also you can do. For example, let me create another in region number, let's say 2. Okay. But once you add the data center configurations, what you have to do? You have to come back to your main configuration. In the main configuration, you have to add the data center. For example, here I'm adding data center 2 and adding DC3, adding DC4, adding DC5, adding. So if you choose the same data center, it will show an error. You cannot add the same data center twice. Okay. So this is data center 7. Now if you click done, then you can see. Okay. So here there is only one data center. In this region we have one data center. This particular region I have 2 data center. Here one, and here also one. Right. So now data center is added successfully. User bases are added successfully. So more or less you are familiar with the main configuration and data center configuration. So we'll go to the advanced step. In advanced step, you can set the user grouping factor. So I have mentioned you these 3 different level. In the first level, there are user bases, which represents a cluster of user which are handled in a single unit. So for example, if I specify here 10 or by default it is 10, it indicates that number of simultaneous user for a single user base is 10. So there are 10 users that simultaneously may want to make a request. Okay, that factor you can decide. Similarly, there is another request grouping factor in the data center, or I am saying VM. Okay, that is the number of simultaneous requests a single application server instance can support. A server can support, let's say, 10 different requests at a time, or a VM can support, let's say, 5 requests at a time. That factor you can decide here. And executable instruction length for request is given as 100 bytes. Here we have user base also we have mentioned. User base also, or in data center. Here also we have mentioned user base also. It is 100 is the data size for request, that is 100 bytes that you can specify. Okay. And I told you about load balancing policy. There are 3 load balancing policy you can see. One is round robin, equally spread current execution load, and throttle. Right. So let me choose another policy, right? I am not specifying the default policy, some other policy I am clicking. Okay. So once it is done, once you configure it, if you want to change any configuration, you can do it. I have not changed any configuration here. So click done. Then there is another button that is called as define internet characteristics. So under the defined internet characteristics, you have two metrics. One is called as delay matrix, another is called as bandwidth matrix. So what is delay matrix? Delay matrix is nothing but the transmission delay between the region. So you can see how many regions we have. We have 6 different regions. So from one region to another region, you can transfer a particular user base. So in a particular region, if you have more than one data center in a particular user base, if you have suppose the user base region is region 0, and in region 0 you have 2 data center. So you can migrate the user base from one data center to another data center in that particular region, or you can move from one region to another region if there is a scarcity of resource. Okay, the resources may be sought from another data center, right? So here you can see if you are moving from region 0 to region 0, the delay is considered as 25 milliseconds. Like that, if it is same region, it is given as 25. You can see the principal diagonal, it is 25. But if you move in different region, for example, region 0 to region 1, so it is 100 milliseconds. And if a region is very far away, for example, let's say region 0 and region 3, they are very far away, distance is very far, then obviously the delay matrix is going to be increased. So it is 250 milliseconds. Similarly, while you are looking into the bandwidth values are also given here. Normally the bandwidth is very high if you are present in a particular region, the same region. But when you take two different regions, generally bandwidth is low, right? So within your network, you can make it very faster. But when you go outside your organization, it is not that much faster, right? So whatever maybe, you can choose these values. So these values are between regions for a particular application, and whatever values we are giving here, that is in Mbps. So if you want to change any value, you can change it. For example, I want to change it to, let's say, 2000, so that I can do it. Let's say I am changing it to, let's say it is 200, so that I can change it, and click done. Okay. So if you want to save your configuration, you can do. If you click save configuration, suppose I want to save it as cloud fog IoT.sim. So I can save it. Okay, later point of time, you can again retrieve and run it, right? So now all setup is now ready, right? Simply you have to click run simulation. So you can see in run simulation. Okay. So UB3 is connected to DC3 as well as DC7. UB4 is connected to DC4. UB6 is connected to DC6. UB5 is connected to DC5. DC2 is connected to UB2. And these user bases are connected to the respective data center. So you can see in this diagram, they are not moving outside their region because the data center capacity is enough to provide resources to their user bases. So if it is exceeding, then definitely as you selected optimize response time, so it will move from one region to another region. But as we have taken very less number of user base and data center, we have taken one data center per region. So definitely you will not find any deviations. All user base and data centers, so those who are located in the same region, they are only exchanging the resources, or they are getting resources, right? So you are not able to see any variance here. And these results are shown with respect to three things, that is average response time, maximum response time, minimum response time. So obviously minimum is less than your average, less than maximum response time. For example, if you see this one, the average response time you are getting is 50.2 millisecond, minimum is 38.6 millisecond, and maximum is 61.4 millisecond. So minimum less than average less than maximum. Okay. So you will get a result here, display detailed result. That result also you can export as a PDF. For example, if you want to take this is cloud, fog, and IoT, so it will be saved as .pdf. Where this is a report, that's why it is stored in PDF. But when you save the simulation file, it is saved as .sim. Sim stands for simulation. So what we have here? So we are getting overall response time. Okay, two parameter is important. One is overall response time. Overall response time means you are calculating with respect to all user base and data centers. Okay. So average overall response time you are getting is 50.12 millisecond, 38.14 millisecond. That is the minimum one. Maximum overall response time we are getting 64.66. Okay. Similarly, data center processing time is 0.49, 0.01, 0.90. So you can notice here there is minimum is less than average, less than maximum. And individual user base wise, UB1 to UB10 wise, what is the average value, what is the minimum value, what is the maximum value that you can get. You can also get user base hourly average response time with respect to each and every hour. Right. For example, our simulation, if you remember, we have taken 100 minutes. 100 minutes means hardly it is 2 hours. Right. So with respect to hour basis, what is the response time that you can get graphically? Okay, like user base, you can get the data center details also. Data center request servicing time. So we have taken 7 different data center. Right? We have taken 7 different data center. So what is their average time? What is their minimum time, maximum time? You can get here. Right. So as the processing time is very faster, I think you are not getting any graph here. Okay, similarly data center loading, you are getting cost also. So this particular setup requires $5.84. That is as a total virtual machine cost. And data transfer cost we are getting $1.07. So if a developer wants to execute these 10 different user base to let's say 8 data centers, sorry 7 data centers we have taken. So the total cost we have to pay to a provider is $6.9. Okay, the details about details with respect to data center also you can find here. What are the BM cost, data transfer cost, and total cost. Okay, so this is a rough estimate. We are getting 6.91 to execute these many number of user base, whatever specification we have given, and if we want to execute in 7 different data centers. Okay. So this is all about the first tool, that is our CloudAnalyst tool. If you have any question, you can ask.
Sir, what's the importance of this tool? Like, why analysts use this tool, and for what information, and how it's helpful to them?
The first thing is that if you go for AWS or you go for Google, Google GCP, Google Cloud, and other things, there you have to pay. Once you exceed some quota, you are going to pay. Like 750 hours is provided by Amazon for using Amazon EC2, 5 GB is provided for Amazon S3, right? But doing some kind of simulation is not an actual environment, but it is a virtualized environment, you can say, or you are taking, you can say, the simulation. We are just creating an environment which looks like an actual environment, right? So it is not. This tool is not taking any money from your provider. It is not charging any money. So in research point of view, first we do simulation. Once we succeed in the simulation phase, then we go for the experimentation purpose.
So what's the what the outcome of this, like the outcome, how that outcome is beneficial, like the
In out
report that
in outcome you are getting the overall cost, what is the debt. If really you set up these many data center and you are making some user base to deploy the machine, right? So overall you are going to pay this much to your cloud service provider. That's why this tool is more significant in research community.
Okay, so how many user base should we establish, and how many data center should we establish, or like whatever the parameters we have adjusted, how many
Mm.
we should do that such that it comes in our budget, like with
Exactly.
vendor.
Before deploying in the actual environment.
Okay, so this is done by the organization cloud analyst, like the in the organization the cloud
Yes.
analyst before uh, getting
Yes.
into agreement with vendor.
Yeah.
They like okay.
So another thing, just I want to tell you about Cloud Analyst. You go through research paper and you will see a class file here. So it is very important to understand, look into this class file, because when you go to NetBeans or Eclipse, whatever may be the IDE, okay, you will find a lot many files. So it is difficult to know what is the dependency, because when you create modules in software, one module may be fully dependent on another module, one module may be partially dependent. Okay. So this is the whole configuration, right? How they have connected. Anyhow, you can get if you go to NetBeans and if you go to project, if you expand the source package, you will see these are the different modules. So I told you about service broker policy. If you open it, you will find the service broker policy files. Suppose, for example, response time. So simply if you click, then you will get it is connected to some other modules also, right? And some code is written. So you have to first try to understand this code if you want to develop a new service broker policy. So simply, if I want to develop a new service broker policy, I'll add a Java file here. But rest of the configuration is as it is. I'm not going to change any configuration, right? So you can contribute to a particular module. Developing a tool is really difficult, but modifying a particular file, it is very easy, right? So it also provides the features to the research community to develop new policy and check that that policy is performing better than the existing policy or not, right? Similarly, you can look into what are the other files. I'm not going in details, right? So you can look into these files if you are command on Java. If you have little bit knowledge, I think you can understand. Under data center, we have round robin policy, throttle policy, and other policies. So I think you can understand this policy and try to implement your new policy in Cloud Analyst, and so that that policy is better than the existing policy. Okay. So this is all about Cloud Analyst. So let us proceed to the next tool, that is called iFogSim. So I have given also that link. If you have not downloaded, you can also copy from my Google
Hello,
Drive folder.
Sanjay sir. Hello,
Yeah. Please, sir.
sir. I have one question here.
Yeah,
Uh,
please.
like I'm working over the container, okay, sir. And
Hmm.
I think this module, I think CloudSim 3.0, 0.3, I think, है ना?
Hmm.
This cloud analyst tools, whatever you have shown here right now.
Hmm.
Sir, actually, I'm facing the problem where I have to write my own algorithm, whatever I have to suppose, and that is the actually problem. If I'm writing also, that output is not coming.
In Cloud Analyst,
CloudSim
Cloud
4.0,
Sim
sir.
or Cloud
No,
Sim
no,
or Cloud
standard
Analyst?
CloudSim. It's standard CloudSim.
Cloud Sim, it is difficult because most of the people is difficult to get the get understanding that particular course what is there in the Cloud
Yes, sir.
Sim.
Yes, sir. Yes, sir. Actually, sir, I tried, but I didn't get actually. I tried it.
Okay, you share your code. If it is possible for me, I'll help you. Okay.
Yeah, sure, sir. Sure.
Yeah. But really, this is challenging because most of the reviewers also asked during our research work. They are asking why don't you use Cloud Analyst? But understanding the Cloud Analyst, again modifying the code, because dependency is more important. If you can change some code in a particular file, and if it is not supported, it is linked with any other file which you have not done, then definitely you are going to get error. Again, CloudSim is also taken from GridSim. Okay, so there is so many dependencies. Earlier in grid computing, we have a tool called GridSim. Now CloudSim. Then now we are saying iFogSim. So more or less all these codes are interrelated to each other. So whenever we are writing code, if we miss one single dependency, then we are getting an error. Okay, anyhow, we'll try to resolve that.
Okay, sir. Okay, I will contact you, sir.
Yeah. Okay. So let me close this one. Okay, I told you to take iFogSim master. But again, there may be some kind of path issues we are also facing when we execute this in our system also. So let me paste it in another folder. Okay, I am putting in that same iFogSim folder. So if you have not downloaded iFogSim master, so go to the day 7 folder. Under the day 7 folder, you have iFogSim folder. So you can see there is a folder called iFogSim master, hyphen master. So it is also a zip file. Just you have to unzip that particular file. Okay, so earlier we have tried with Eclipse. So like somebody asked about why Eclipse, why not NetBeans, or in the first case, why NetBeans, why Eclipse. It is possible in any Java IDE, but we need to understand that what are the minimum linkage or path setting required to run these tools. That actually we need to understand. Sometimes we are getting error because of that. Okay, let me open Eclipse. So I have Eclipse in my system. So sometimes also these tools are not supported by the latest softwares. Right? If you go for the latest Java IDE of Eclipse, also sometimes it is not supported. So compatibility issues are there. So just like we can stay hit and trial method to solve this problem. Okay, once Eclipse is ready, so let me delete this one I've created earlier. Okay, so like CloudAnalyst, we have created or we have opened that file as a Java project. So here you can create a Java project. You can mention the Java project name is, let's say, Cloud, Fog, and IoT. Some name you can provide. Okay, and there is a default location. It is you can see here. The default location is it is showing Eclipse workspace space and this name. But this one, this location you have to give as our Cloud Analyst, sorry, our iFogSim master folder. So under new folder, I have iFogSim master. Okay, so I'm giving this folder as input. So in my desktop, I have created a new folder. I have not given any name. Under that, iFog master is there, which is a unzip file. Under that, iFogSim master is there. That path actually I am giving here. Then you can finish it. So it is asking us to create some file. There is no need to create any file. So now my Cloud Fog IoT, you can see this is a project, Java project, right? Like we have seen in the earlier case in NetBeans, that CloudAnalyst is a CloudAnalyst is also a Java project. Here is also Java project. Again, if you go inside this code under the SRC, you can see a lot of folders, and some of the folders are matching with our CloudAnalyst. That means on top of CloudSim only we are doing it. That's why I told you there is a dependency: GridSim, CloudSim, then iFogSim. And its GUI file is available under, I think, example. Let me check once. If you expand it, you can see there is a fogsui.java. You have to run this particular file. So you have to run as a Java application. So what I did, I am telling you again. Later point of time, you can follow my video, right? So I have created a Java project with any name. I've given our FDP name, that is Cloud Fog IoT. And once you create this particular file, then it will ask you your default location. So change the default location to your iFogSim master folder. Under iFogSim master folder, there may be multiple iFogSim master folder also, right? So you have to give the folder in which inside you have bin files and other files are there. Right? For example, if you go to the next new folder, inside that you can see under iFogSim master, another iFogSim master is there. But inside that your bin, jar, output and other files are there. So you have to give the link of this particular folder. Don't give iFogSim master. Okay, you will get an error. It will not reach to that one and it will show an error, right? Then you have to expand your SRC. Okay, under SRC, note down the folder name is org.fog.gui.example. Under that, we have foggui.java. So you have to right click and run a Java application. Then you will get a file like this. You will get a you can see a picture like this. Earlier you got a in CloudAnalyst case you got CloudAnalyst you got a world map, right? So in this case you will get a fog topology creator. So this is a fog topology creator. Okay, so what we have here? Here you can see in the first button which shows is a set of sensor. This is a set of actuator. This is the fog device or cloud device. And this one is to connect your sensors with your devices or actuator with that device, right? So sensor, if you want to add a sensor, you have to click here, add actuator, and this one is add fog device, and this is add link, and this is to if you want to open some existing topology that is given in the cloud iFogSim. And this is to save your topology, whatever if you have created, and this is to exit. So let me show you a popular topology which is already there in our folder. So in desktop, I have my new folder. Under new folder, I have iFogSim master. Under that, iFogSim master is there. Under that, we have topologies. Under topology, we have a topology that is called as VR underscore game underscore TOPO topology or copy of VR game topology. Okay. Any topology you can open. These are the topologies that are there in iFogSim. So if I open it, then you can see there is a topology. It is blurred. So when you little bit adjust it, it will show it properly. So although I have not told you about this IoT fog and cloud architecture, I have a special lecture in the last day in which we will see a new computing paradigm, that is osmotic computing, in which we have IoT fog cloud architecture. And we have seen little bit about IoT fog cloud architecture on the last Friday, where I talked about fog computing, role of fog computing in vehicular ad hoc network using 5G network. So in this topology, what you can see, that this is a actuator. A stands for actuator, right? A stands for sensor. So for example, I can say, let's say, for example, if you go for agriculture land, the soil moisture sensor can be considered as a sensor. But once you find something in soil moisture sensor that, let's say the agricultural land is not getting water, then let's say you instruct the actuator, which is a motor, to supply the water, right? So sensor and actuator both are needed, right? Sensor collects the data and actuator performs something, right? As a human being, you can say our eye is a sensor, right? We can look something. Suppose I am going somewhere, I have seen a snake. So my eye is able to detect that is a snake, and our actuator is our leg, right? Through leg, we have changed our movement from one direction to another direction. Similarly, here also we have actuator, we have sensor, we have actuator, we have sensor, actuator, and sensor, and we are giving different IDs to distinguish one actuator with the sensor. So this is sensor 00, sensor 01, sensor 10, sensor 11. And sensors are connected to a fog device. There may be multiple level of fog also. For example, here you can consider this M layer and D layer. They can be considered as fog layer. Okay, M00, M01 is one layer. D1 is another layer. M11, M10, that is another layer. On top of that, we have another layer, that is D2. So we have two layers. Right? You can create more layer based on your research application. You can create as many as number of fog nodes, as many as number of fog layers. So these fog devices are connected to the cloud through a proxy server. Okay. So when you open a particular topology, you can see in the dashboard, or I can say console. If you go back to the console, you can understand. Let me open it side by side. So in console, you can see something is printed, already printed in the output screen. So try to understand this one. What it says that your start node is M11. Where is M11? This one is your M11. Which one is your target node? Target node is D2. So M11 passes some message to D2. D2. Similarly, start node is A11. That is my actuator 11, which is connected to M11. So A11 is communicating with M11. That is start node to the target node. Again, the start node is proxy server. Target node is cloud. Right? The communication, which you can see, all the communications are in upward direction. Right? Similarly, start node is M01. M01 is a fog device and target node is D1. Start node is M10, which is also a fog device connected to D2, another fog device. Start node is M00. Start node is M00. Target node is M00 to D1. Start node is A00. A00 is an actuator device which is connected to a fog device, that is M00. And start node is A01. A01 is a actuator which is connected to A00. Sorry, A00 which is connected to M00. Start node is A01 which is connected to M01. And start node is A10. A10 is here which is connected to M10. Similarly, start node is my D1 connected to the proxy server. Start node is D2 which is connected to proxy server. Similarly, start node is SO01. Target node is M01. Now sensors are communicating with the fog. Start node is S10, M10. Start node is S00. Target node is M00. Start node is cloud, but cloud is not sending the data to anywhere. It is only receiving the data from the fog device. In this particular case, you can do a new topology where you can connect, or you can set up a new topology where there is a bidirectional movement is there. Start node is S11 and target node is M1. Okay. So these are the connections which we found in a fog device. Okay, from fog device, or you can say from cloud, or from sensors and actuators. Okay, so now if you want to create your own topology also, that also you can do. For example, let me exit this one and let me read on again. So this I am showing you, which is already available in CloudAnalyst, our iFogSim. And if you want to create your own topology, for example, I want to set up in cloud, let it be level number 0. You can specify what is the uplink bandwidth and downlink bandwidth. So in CloudAnalyst also you have seen these bandwidth concepts. So I am putting a very large value. Suppose MIPS is, let's say, 2048 something something. RAM speed also you can mention. Rate for MIPS also you can mention. So now you can see a cloud is created here. Okay. So I am adding next a fog device. I am writing fog device 1. Level is 1. Up link I am giving some random value. Down link also some random value. Let's say 1024. Let's say 2048, something like that. So you can see I have created a fog device. I have created a cloud device. I have created a fog device. So whatever you are creating, you can see the changes in the console. Like previously I saw, here also you can see in the console. I have created start node, I have created the cloud, but till now I have not connected the start node with the cloud. So it is showing only the start node. Okay, now I am connecting sensors. So I am writing, let's say sensor 1. Let's say what type of sensor it is. You can mention whether it is a temperature sensor or some sensor. You can specify which distribution it is following. If you say normal distribution, you have to write the mean value and standard deviation value that we have seen in the mathematics. If you choose uniform distribution, you have to specify the minimum value and maximum value. Getting sensor number 2, type I am specifying, let's say humidity or some random thing I can write humidity. And let's say distribution type I am writing normal and specifying, let's say mean is 10, some 10 and standard deviation is 5. So these are the random values I am putting here. So I have created a sensor. Similarly, if you want the actuator, you can write actuator A1. So actuator type is, let's say A1. So it is added. Similarly, I am adding another actuator A2. Actuator type is A2. So I have created another actuator. Now, in order to connect these devices to each other, so you can see console case also. All are considered as a start node because I have not connected. Right? A2, fog1, cloud, S1, S2, A1, all are considered as a start because there is no destination till now. So there is a LAN cable symbol here. So once you click it, and for example, I am selecting S1 here, sensor S1. So it is saying sensor 1 can be connected to fog or cloud, right? Upward movement. Let's say the delay is 10 millisecond. So you can see sensor is now connected to fog. Similarly, I want to connect, let's say actuator A1 to fog with a latency of, let's say 5 millisecond. So now A1 is connected to fog 1. Okay. Similarly, suppose I want to connect, let's say sensor number 2 to fog 1. If there are multiple fogs out there, you can connect, let's say one to fog 1, another to fog 2. But I have created only one fog node here. And like, let's say latency is 100. Similarly, I am creating another actuator, sorry, another connection in which I am mentioning actuator A2 is to connect with the fog with 30 is the delay. So now all sensors and actuators are connected. See the console? It is saying start node is A2 connected to fog 1. Fog node has started, but that has not ended. Start node is cloud. Start node is S1. It is connected to fog node 1. Start node is S2. Target node is fog 1. Start node is A1. Target node is fog. But till now, we have not connected fog to the cloud. So simply, you have to click fog 1 is now connected to, let's say, cloud with a delay of, let's say, 10. So now it completes our topology. Right? You can see start node is my fog 1. Yes, here you can see start node is fog 1 and target node is cloud. That is added. Okay, so similarly, you can create your own topology. iFogSim supports different type of topology if you want with respect to different type of application. So there is a paper by Professor Somyakanti Ghosh from IIT Kharagpur with Professor Rajkumar Bhuya from University of Melbourne. There they have shown different type of applications in which different type of topologies they have used. So you can refer that paper and create a different topology with respect to some targeted application. But this tool is also having some limitations, like we are creating different kind of sensors and actuator without providing a different sensor type. For example, like temperature case, I have taken the temperature is 10 to let's say 40. Let's say another sensor case, the limit is let's say 100 to 200. So user has to select that one, right? User has to specify that. User has to specify whether it is a normal distribution or uniform distribution or any other distribution. So, but if these distributions can automatically selected based on the sensor type or actuator type, then we can extend this particular tool. Similarly, different type of placement strategies are also there. So there is some cloud placement strategy, there is some edge placement strategies you can refer in that paper, and you can develop your own type of placement strategy. And if you can show that your placement strategy is better than the base strategy, then that can be also one of the contribution in this particular field. Okay, this is all about these two tools. So you can explore this tool and make use of this tool in your respective application. Yeah, if you have any question, you can ask.